Welcome back. In this video we're going to solve problem 44 of the section covering finding the parameterization of surfaces and their surface areas. So problem 44 asks us to find the surface area of the part of the surface z equals 4 minus 2x squared plus y, which lies above the triangle generated by 0, 0, 1, 0, and 1, 1. Those are the three vertices. So as always, the most important thing is to first try to plot your graph, your domain. Okay, so I'm going to give you a moment. Go ahead and pause the video and work on this yourself. Okay, good. So hopefully you got it. Let's work on it. So here are the points that make up my triangle, and these two curves are, well, you know what they are. This right here is y equals x, right? And this is the point 1, 0, 0, 0. Oops. I don't know where I am today. 1, 1, and 1, 0. Okay, so if I keep this in mind, this is what I'll need for my domain. Okay, so what I want to do is I want to integrate over my domain D, and I'm going to go ahead and just use the formula that I derived in the last video. Hopefully, you don't just memorize it by staring at your book and repeating it and writing the formula a billion times. That's a bad way to memorize things. The way to memorize it is by solving lots of problems. And if you've done this, the formula should stick. So I'm just going to go ahead and write it. So it is this, correct? And, well, what is f? What is f of x? Well, f is this right here. F is z. So the derivative of f with respect to x is minus 4x, and f with respect to y is 1. So I'm gonna integrate in this direction, right? So vertically, we almost always go vertically on our inside integral. It just happens that way. Okay, so the outside bounds are going to be 0 to 1, and inside I'm going to go from 0 to x. And if I write this out, if I square this, I get 16x squared, and I pick up another 1 squared, and this is going first with respect to y and then with respect to x. So you should get 0 to 1, 0x, 2 plus 16x squared, like this. Now I'm gonna have to integrate this y because I need to do a u substitution, right? So if I do that, I go from 0 to 1, I pick up a y, and then that's going to become an x. Right? Pick up a y, evaluate it from x to 0, so I pick up an x. And then I should let u equal 2 plus 16x squared, so that du equals 32x dx. So if I multiply like this, this will allow me to carry the calculation out. So if I rewrite it, I have 1 divided by 32, and plugging in 0, I get 2, plug in 1, I get 18. Square root of u du, and, well, the rest is The rest is very easy, so I'll cut the video here.